Hello everyone, welcome to the Screencast. My name is Rowan and my surgery project is Automatic Facial Expression Recognition. Let's start from the definition of the problem. The task is, given the raw image data containing a face, we need to predict the facial expression the given face represents. Such a system can be an important component of natural human-machine interfaces, or alternatively, it can be used in behavioral science and clinical practice. Facial expression and emotions recognition is a challenging task that has attracted much research potential in the field of artificial intelligence. A key challenge is achieving an optimal pre-processing, features extractions, and classification, taking into account input data variability. High input data variability is a result of the following factors. View opposed of the head. While we can mitigate translation, rotation, or scaling of input images using multiple pre-processing techniques, the effect of out-of-plane rotation results in high input data variability, making it extremely difficult to reliably recognize emotions. Environment clutter and elimination. Occlusion, complex image background, and uncontrolled lighting can result in poor recognition performance. These factors can lead to features extractions, contamination by unrelated information. Facial variability and blending. There is a high degree of variability due to a number of factors, such as differences across people arising from race, age, or gender, facial hair, makeup, or even blending of several facial expressions. Some emotions are extremely hard to distinguish. For instance, some people express sadness similar to a neutral emotion. This project relies on the convolutional neural network for reliable emotions recognition. Convolutional neural network is an example of feed-forward neural network for processing data that has no grid-like topology. They are similar to ordinary neural networks but use a convolution operation instead of multiple general matrix multiplication in at least one of their layers. Convolutional neural networks have been tremendously successful in practical applications. Facial expression recognition 2013 dataset, generously provided by the KGO website, has been used to train the convolutional neural network. It contains 35,830 well-structured 48 by 48 grayscale images. The implementation of convolutional neural networks has been provided by the Caffe deep learning framework. In order to speed up the training process, the GPU capabilities have been exploited. The resulting model has been tested on FER 2013 dataset. It has achieved 69% accuracy, similar to the state-of-the-art results obtained by Microsoft researchers Yu and Zhang. As a result of this project, a real working system has been developed. It is capable of real-time emotions recognition given input images obtained from a web camera feed. Additionally, it features a real-time face detection using the state-of-the-art techniques. Furthermore, the system visualizes activations at each layer of the network. This allows us to gain a valuable insight into how the network operates and what facial features contribute to the decision-making process. The system learns the network architecture on the startup and displays the corresponding activations table for each individual architecture. It is smart enough to ignore layers that do not contain any activation maps, such as fully connected layers at the end. Only first 10 activations for each layer are displayed on the main screen. All per-layer activations can be accessed by clicking on the Show More button. We will demonstrate this functionality a bit later. Let's see the system in action. Welcome our first user, Marcus. He starts off with a neutral emotion and additionally demonstrates the robustness of the system to the limited head rotation. He follows up with a happy emotion and again showcases the limited rotation invariance. Marcus briefly shows a fearful emotion and the system positively classifies his facial expression. He then follows up with a surprised expression, commonly identified by wide open eyes and an open mouth. He now expresses an angry emotion and the system yet again correctly predicts it. And finally, he demonstrates a sad emotion. Let's welcome our second user, Rowan. This time, let's pay attention to the activations of the fourth convolutional layer. There are 128 activations at this layer. If we carefully analyze each of them, we can infer the network primarily focuses on the shape of eyebrows, eyes, nose, and the mouth. Some filters have learned to focus on the cheekbones, forehead, or even the bridge of a nose. Such an analysis provides a valuable insight into how the network transforms the input volume and what facial features are considered important. Now, let's see Rowan testing the system. He starts off with a happy emotion, which is recognized virtually without any effort. He then follows up with a surprise emotion, which also has very distinctive characteristics. Next, he demonstrates a sad emotion. In this case, we can see the system has a dilemma between a sad emotion and a neutral emotion. This is due to blending of these two emotions. Finally, Rowan demonstrates an angry emotion, followed by a disgustful emotion. The system has been able to correctly identify these two facial expressions. The second deliverable for this project is an application for mobile devices running Android. It has a simple and intuitive user interface. The starting screen prompts user to choose between two options, either use stored images or a camera feed as an input source to the network. Let's consider each option separately. We shall start from the camera option. A real-time face detection is being carried out on the input from a camera using Android built-in face detection capabilities. All detected faces are marked with a rectangle. The system can track multiple faces simultaneously. In this case, separate predictions for each face will be provided. We will demonstrate this in action a bit later. The mobile system does not feature real-time recognition, as it merely does not have enough processing power. Instead, it offers on-demand emotions recognition. Upon clicking on the capture button, an input image will be run through the face detection phase. From there, all detected faces will be propagated through the network. Let's see this in action. We get back to markers. He starts with a neutral emotion, followed up by a happy emotion. The system correctly predicts both. He then poses a surprise emotion. Yet again, the system has no problem recognizing it. Next, he demonstrates an angry emotion, which is indicated by eyebrows down and together, and also narrowing of the lips. Finally, he expresses a sad emotion, characterized by dropping of upper eyelids and slight pulling down of lip corners. The system has classified it correctly. Now, let's try it with two people. Marker and Rowan post happy emotions. The system has managed to detect the faces and marked it with rectangles. It now has correctly predicted individual emotions. And the same scenario, but with a neutral emotion this time. Let's now try to use a stored image as an input source. For this test, an image with 6 different people has been prepared. The system has to detect all faces and produce individual predictions for each of them. We can see the system has managed to correctly localize faces and provided us with predictions. This wraps up today's screencast. Thank you for your attention.